we are not just going to be looking at mathematics questions alone, but we will also look in the area of physics, chemistry, and further maths. So we have a question with us that we are going to solve. It is an interesting question. I know this question, I've been seeing it somewhere. A lot of students have been battling with it. That's why I have given it out in order to solve and help students. A body at rest is given an initial uniform acceleration of 8 meters per second square for 30 seconds, after which the acceleration is reduced to 5 meters per second square for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. Question number 1. Draw the velocity time graph of the motion using the information given above. Using the graph, calculate the maximum speed attained during the motion. The answer is 340 meters per second. Average retardation as the body is being brought to rest. Answer is 17 meters per second square. Total distance traveled during the first 50 seconds. Average speed during the same interval as in 3 above. Answer is equal to 188 meters per second. Meanwhile, don't forget to click the subscription button and don't forget to share it with your friends. Share it, like it, and also put on the notification so that you will be aware of anytime we are uploading new videos. God bless. We are going to start with the drawing of the velocity time graph, but let's write out some parameters. The first acceleration given in the question is 8 meters per second square. And the body maintains this acceleration for a period of time, 30 seconds. But don't forget, whenever there is acceleration and time, speed will be attained. The second acceleration is equal to 5 meters per second square. And the time interval for this acceleration is in 20 seconds. The car attains the maximum velocity. We call it V2. So these are the things we are going to be calculating in the question. But don't forget, because the body started from rest, we take u to be equal to 0. Let's draw the velocity time graph. The body started from rest. That means the motion started from the origin. And then reduces the acceleration. When acceleration reduces, the steepness of the slope changes. Then the body maintains the speed attained at the end of the 5 meters per second square. And then it was brought to rest. This is the motion of the car. The green line represents the first part of its motion. That is 8 meters per second square, the acceleration there. Now this is the velocity time graph. Let's include the time intervals. A car starts from rest and accelerates for 8 meters per second square for 30 seconds and reduces the acceleration to 5 meters per second square. For the next 20 seconds. That is 30 plus 20. It now maintained the final velocity gotten in the next 60 seconds. 60 plus 50, we are going to have 110. And it was brought to rest in the next 20 seconds. 110 plus 20, we have 130 seconds. So the next thing now, we are done with the velocity time graph. This is the velocity time graph. The velocity at the origin, let's take it to be u. The velocity at this particular stage, let's say it is v1. And the velocity at this particular stage, let's take it to be v2. The second question is to calculate the maximum velocity attained, which is our v2. We are going to be using two approaches to solve this same question. I'm going to use the velocity time graph and also use equation of motion for you to see the similarities between velocity time graph and equation of motion. Under normal condition, if I'm going to calculate my v2, because acceleration is a function of slope, change in v here over change in t. But for me to calculate my change in v, which is going to be v2 minus v1, therefore I need v1. I need to go and calculate v1. So my v1 will be this change in v over this change in t. So we get v1 first before we get v2. Acceleration is equal to change in V over change in time. For the 8 meter per second square, I have V1 minus U all over. The time interval is 30 minus 0 because the time at the origin is 0. 30 minus 0. So I have 8 is equal to V1. The initial velocity is 0. The velocity at the origin, 30 minus 0. Therefore, my V1 is equal to 8 times 30. V1 is equal to 240 meter per second. This is the velocity attained at the end of the 8 meter per second square acceleration. Now we are going to calculate the velocity attained at the end of the 5 meter per second square acceleration. See the same formula, acceleration is equal to change in V over change in T. 5 is equal to, our change in V now is going to be, let's go back to the diagram, V2 minus V1 all over 50 minus 30. 5 is equal to V2 minus 240 over 20. This is the final velocity, that is the maximum velocity attained at the end of the 5 meter per second square. I told you I will be using two methods in solving this equation, both equation of motion and velocity time graph. If you are not careful enough, you may not be able to use equation of motion directly, but see how it goes. For the first part of motion, where we have acceleration to be 8 meter per second square. The car started from rest, I have to calculate my V1. So I use this equation of motion. V is equal to U plus AT. Therefore, V1 is equal to U, which is 0, plus the acceleration is 8. And this motion takes place for the first 30 seconds times 30. V1 is equal to 240 meter per second. Now we are going to take this V1 to be our new initial velocity, 240, for a car that has an initial velocity of 240 meter per second, has an acceleration of 5 meter per second square. Calculate the final velocity after 20 seconds. That is the question. A car traveling at an initial velocity of 240 meter per second accelerates for 5 meter per second square. Calculate the final velocity after 20 seconds. So we use this formula, V is equal to U plus AT. Therefore, V is equal to what? 240 plus 5 times 20. V2 is now equal to 240 plus 100. Therefore, V2 is equal to 340 meter per second. We got the same answer using different methods. Question number 3. Calculate the distance traveled in the first 50 seconds. So the distance traveled in the first 50 seconds. We have to go back to the velocity time graph. If you take a look at this diagram, for the first 50 seconds, this is the motion of the object. Or this is the motion of the car. This particular area, like this. So the motion of the object can be grouped into two. The first part of the motion and the second part of the motion. To calculate the distance under a velocity time graph, we make use of the area under the velocity time graph. In the first diagram, we have a triangle, while in the second diagram, we have a trapezium. So we are going to calculate the distance covered under the triangular diagram and then the area of the trapezoidal diagram, and we add it together. Therefore, D is equal to D1 plus D2. D1 is the distance under the triangular diagram. D is the distance under the trapezium diagram. (240), 0. The distance from here to here, from here to here, is 30 seconds. So let's calculate the area of the diagram. Area of a triangle, which is equal to my D1, is equal to what? Half base times height. This is my D1. D2 is now equal to area of a trapezium 1 over 2 into bracket A plus B, then times height. (240 plus 340), then the distance between them is 20. D2, 2 goes there 1, 2 goes there 10. 240 plus 340, 580. Therefore, the distance traveled for the first 50 seconds is D1 plus D2, which is equal to 3,600 plus 5,800. The total distance traveled for the first 50 seconds is equal to 9,400. I told you we can still use the equation of motion to calculate everything we are calculating under velocity time graph. S represents the distance, A is the acceleration, and T is the time taken. But we cannot calculate this distance straightforward. We have to group it into two because the acceleration is into two forms. We have the first acceleration, that is the first stage of the motion, and the second stage of the motion is the second acceleration. So for the first stage of the motion, where we have 8 meters per second square for 30 seconds, we calculate the distance. S is equal to, the initial velocity is 0 because the object started from rest. So I have 0 plus 1 over 2 times the acceleration is 8, then times the time, which is 30 seconds, 30 square. S is equal to 2 goes there 1, 2 goes there 4. 4 times 30 squared. S is equal to 4 times 900. S is equal to 3,600, as we have gotten before for the first distance under 8 meters per second square acceleration. For this second distance, is going to be the distance traveled for an object that has an initial velocity of 240 meters per second and accelerate at the rate of 5 meters per second square for the next 20 seconds. 240 times 20 times 1 over 2 times 5 times 20 squared. We have 4,800 plus 5 over 2 times 400. Therefore, the total distance covered for the first and the second acceleration is given as 3,600 plus 5,800 meters, which is equal to 9,400 meters. We have calculated the distance traveled in the first 50 seconds. Calculate the average speed during the first 50 seconds. Therefore, the distance covered in the first 50 seconds is 9,400 meters. Speed is equal to distance over time. S is equal to 9,400 over 50. This is the answer to the question. Okay, actually we have calculated this and we have calculated this, but there's a question here that we need to calculate. average retardation as the body is being brought to rest. This is the part of the motion that represents retardation. And the body comes to rest directly from this velocity, v2, which is equal to 340 as we have calculated. And the time interval is 130 minus 110. From our velocity time graph, we have something like this. This is 340, and here is 0. And the time interval here is 110, while here is 130 seconds. So we have 20 seconds interval here. The average retardation as the car is brought to rest is a function of the slope of the graph at the later stage. We have A is equal to 340 minus 0 over 110 minus 130. 34 divided by 2, I have minus 1. Remember 1 in 14, I have 7 meter per second square. This is the rate at which the object is being brought to rest. It is negative because it is retardation or deceleration. Okay, let's use equation of motion to calculate this. An object has an initial velocity of 340 and it is brought to rest. Final velocity is equal to 0 when an object is brought to rest under a time interval of 20 seconds. We use V is equal to U plus AT. The final velocity is 0, then is equal to 340 plus A times 20 minus 340 is equal to 20A. Divide both sides by 20. A is equal to minus 17. It's a negative acceleration, that is retardation.